Good morning, dear students. This is your professor, Dr. Vaibhav Pandit, Assistant Professor and Head, Department of Soil Science, School of Agriculture, SRU Warangal. Today we are going to discuss about the weathering and soil formation, how weathering is important to develop the soil profile. This is the content of today's class, that is introduction, weathering type, weathering process, weathering sequence, soil formation and different soil forming factor. Let us discuss about this diagram. It will explain how weathering is different from the soil formation. So we will see here, this is the bedrock, means this is the rocks, and rocks will have different types of minerals. This bedrock is a consolidated bedrock. We will convert it into the unconsolidated material. That one we can see the bigger size bedrock will convert into small size bedrock through the weathering process. Through the weathering process. So conversion of bedrock into the unconsolidated bedrock or the smaller size bedrock through the weathering process. Okay, this unconsolidated bedrock, it acts as a paramaterial or regolith for the formation of soil. From this unconsolidated bedrock, we will get the one profile. In that profile, we'll have the 5 master horizon. Okay, 5 master horizons. So for the formation of the soil, so unconsolidated bedrock will act as a parameter. The difference between the weathering and the soil formation will form from the unconsolidated bedrocks, or also we can see the paramaterial. This paramaterial will form from the bedrock, consolidated bedrock, to the weathering process. Okay, so weathering is on today's video we are going to see about the weathering and soil formation. So let us start from the weathering. Okay, so we are discussing here the weathering of rocks and minerals. Weathering is the disintegration and decomposition of rock and minerals by the different process, like physical, chemical, and biological process. So the weathering done by the physical process is called physical weathering, and the weathering is done by the chemical process called chemical weathering, and the weathering is done by the biological process, that's called the biological weathering. And these types of weathering is happening in the environment by the different factors or different elements present in the environment, like temperature, rainfall, then microorganism, man, wind, atmospheric phenomena. This one is going to help to do the weathering. So generally, weathering will have the two types. That is the geological weathering and the pedological weathering. So geological weathering will develop the parametrics. Will develop the parametrics, whereas the pedological weathering will develop the soil. Means we are studying in the weathering of rocks and minerals, we are studying the geological weathering. When we will discuss the soil formation, that time we'll discuss of the pedological weathering. So weathering in product will be the parameters, or we can say the regolith. So in this diagram, we will discuss how soil and the regolith is different. So, as we have discussed in the last slides, bedrock is the consolidated material. From this bedrock, unconsolidated material will form, that is called the regolith, which will act as a parameter for the formation of soil. Okay, there is soil is developed by the different factors, and the regolith is formed because of the different factors. The basic difference between the soil and regolith we can identify based on the soil profile. Soil profile have the two master horizons. When we consider the soil, we are considering only two horizons, that is A and B horizons. When consider the regolith, we are considering the C horizon, that is A, B, and C. So combination of A, B, and C horizon is called the regolith, whereas the soil is only the combination of A and B horizons. Coming to the rock cycle. So rock cycle will describe about the formation of different rocks. In rock cycle, first one is we are going to discuss about igneous rock. This igneous rocks is developed from the magma. Okay, that magma is coming on the earth surface, or sometimes it is within the earth surface, and will develop the igneous rocks. That igneous rocks is converted into the sedimentary rocks because of the different environmental factor. And the first steps of the formation of the sedimentary rock, that is weathering, after the transportation, deposition, and diagenesis. From this four process, sedimentary rock is formed from the igneous rock. So both igneous and sedimentary rocks go into the metamorphism because of the high temperature and pressure and form a new rock, that is the metamorphic rock. So these igneous, sedimentary rocks and metamorphic rocks will have the different types of the minerals. So generally, minerals is the combination of the hard mass. No, rocks will be the hard mass will have more than two minerals. Now coming to the processes of weathering. So first, there are three different processes of weathering, that is physical weathering, also called mechanical weathering. Second one is the chemical weathering, and third one is the biological weathering. So first one we'll discuss about the physical weathering, how physical weathering will weather the consolidated bedrocks. So coming to the physical weathering, so just we'll discuss about the physical weathering, how physical weathering will work out. Physical weathering will just disintegrate the rock from higher size to the lower size. It is not going to change the composition of the rock. Means physical weathering will not develop the new rock. It just disintegrate the bigger size of rock into the small size rock. If you will compare the physical weathering, we can compare with the disintegration of rock by the hammering process. The hammering, what hammering we will do? We will, if they have a bigger size hammer, we will just disintegrate higher size of the rock into smaller size. Same thing is going to happen in the physical weathering or the mechanical weathering. So physical weathering and mechanical weathering will work out in the environment by the different factors. So in the physical weathering, temperature will helpful, then the water is there, then the glacier is there, wind is there, and different atmospheric phenomena is there. First factor we are going to discuss about physical weathering, that is the physical condition of the rock. What is the physical condition of the rock? Now, first factor, important factor for the weathering is the water. Without water, the rocks is not going to the weather. Okay, maybe the physical weathering, chemical weathering, or biological weathering. Water is the main important factor. If the rock have the more permeability for the water, that rock will weather fastly compared to the those rocks will not have the permeability to the water. More the permeability to the water, more the weathering of the rock. Suppose we will go to discuss one example, one or two examples here. Consider coarse texture rock is there, that is sandstone, but it is porous in nature. Porous structure is there, and another rock is there, the fine texture rock, that is basalt, but it is solid in nature. It will not have the porous structure. Porous texture rock, that is sandstone, will have the porous structure, will weather more rapidly than the fine texture rock, that is basalt, will not have the porous structure, means the non-porous structure. So the weathering of the coarse texture sandstone will have the porous structure because of the more permeability of the water. Okay. First only I discuss, more the permeability of the water, the weathering of the rock will be faster. Now second example is the unconsolidated volcanic ash will weather more quickly as compared to the unconsolidated coarse deposit, that is the gravels. The organic ash and gravels in the both will have the sporous, and spore phase will be there. Both have the sporous structure, sporous in nature, but the volcanic ash will have the porous between and within the particle, but in the gravels, spores will have between the particle, not within the particle. That's why the weathering is faster in the volcanic ash as compared to the unconsolidated gravels. This physical condition is very important for the weathering of rock. If weathering maybe because of temperature, maybe because of water, or any different of agency, physical condition is very, very much important. The first topic, first point in the weathering, physical weathering. Next, coming to the temperature, how temperature is helpful for the weathering of the rocks. How temperature will bring the physical weathering. Okay, generally we'll say the rock will get heated by the sun, then that time it will expand. During the night time, it will get cool, that time it will the contract. The heating, expansion, and contraction behavior of the rock will helpful for the losing of the outer surface of the rock. We know that the rocks will have more than two minerals, that each mineral will have different coefficient of expansion at a particular temperature. Suppose the rock is there, one rock will have the quartz and the feldspar. The quartz will expand double than the feldspar. Because of the different expansion coefficient, the rock inside it will become loose, it will become the weak. When it will start become the weak, after some time it will get disintegrated. Okay, but there is a dynamic changes in the temperature. The surface of the earth will start removing because of temperature. This phenomena is called exfoliation. Exfoliation is the peeling of the earth surface because of the dynamic change in the temperature, that is called exfoliation, is mostly occur in the granite types of the rock. Now we can see here, this is the granite type rock. Here the removing of the surface layer of the rock, that is the peeling off, or the phenomena is called exfoliation. This is happening because of the annual changes in the temperature day and night time. Here daytime temperature will be high, okay, and night time because of this daytime temperature is high, inside is cool. Here it will be more, inside it will be less. Okay, because of that, rocks will contract, expansion, construction, it will show, and the layer of the rocks will become loose. Then it will start a disintegration. So like this, one layer will remove, second layer will remove, third layer will remove, and like that, different water, different numbers of layers will remove. So because of removing of the layer one by one on the earth surface, because of this phenomena, this weathering is called onion types of weathering. Like onion, we will see one layer will be there, second layer will be there, third layer will be there. Like that, weathering will start disintegration. One layer will disintegrate, second layer will disintegrate, then third layer will disintegrate. Because of these types of phenomena, this weathering is called onion types of weathering. The next one is the action of water, how water will disintegrate the rock. So we know that water acts as a disintegrating, transporting, and deposition agent. So it will first disintegrate, then disintegrate material it will transport from one location to other location, and it will deposit somewhere. Mostly it will deposit near the delta of sea, or maybe in the sea, or maybe in the lake. So based on the deposition, we have given the name. The most important here, how water will bring the disintegration. We know that water, when it will move, it will show the cutting and carrying effect. Cutting and carrying effect means it will move. When it will come in contact with the different rocks, it will show, it will exert some pressure and start the disintegration. Because water will come in the contact, it will start losing, and it will start, it will disturb the structure of the rock, and it will get disintegrated slowly, slowly. Okay. Now the disintegration, it depends on how much the water will carry the load. More the load, more pressure exerts on the rock, and more the disintegration will occur. Okay. And also it depends on the how much long it will transport. Okay. And the transportation power of the water, it depends on the velocity of the water. More the velocity of more water, more the transportation power, more the carrying capacity, and more the disintegration of the rocks. The transporting power is the sixth power of the velocity. Okay, the transporting power will be the sixth power of the velocity. Now we will see here, we have, I see the carrying capacity of fine sand. For carrying capacity of fine sand, speed will be the velocity of the water will be 15 centimeter per second. Okay, the carrying capacity of gravel is 30 centimeter per second. The stone carrying capacity is 1.2 meter per second and builders carrying capacity 9 meter per second. Okay, so water is acts as the erosion as well as transporting effect. It will show the erosion transporting effect. So the disintegration mainly depend on the how much load it is carrying. More the load, more the disintegration of the rock. Now when water will carry the load, the more the load, then the carrying capacity will reduce. It will not carry for the longer distance. When it will not carry for the longer distance, it will deposit somewhere. It will deposit somewhere. Okay. Where it will deposit, there it will develop the one course, river course or one delta. That one is called the minder. That one is called the minder, and the deposit is called the alluvium. And the deposit is called the alluvium. If the river is carrying the deposit, or carrying the sediment, okay, and it is loading and transporting into the sea, that sea or near to the sea, that sediment, that deposit is called the marine deposits. If the river is transporting the sediment and deposit into the lake, that deposit is called lacustrine deposit. So based on that deposit, different soil will form and different properties will be there. So coming to the next factor for the physical weathering, that is the freezing. Freezing is mostly active in the cold region and is more effective than the heat. If you see this diagram, we can easily understand the effect of the freezing. Now the rock is there, rocks will have the crevices, also we can say gaps or the joints. In the joint, water will go inside. Okay. After going in the cold region, that water will get the freeze. Okay. Because of sudden change in temperature, the water will get the freeze. When it will get the freeze, when it will get freeze, then the volume of this water, ice will increase by the 1/9. When it will increase the volume, it will exert the pressure, the wall of the rock, both sides. Okay, when it will increase the pressure, rocks will get disintegrated. That rocks will get disintegrated. This is the process of disintegration of rocks because of freezing process in the cold region. Then next one is the alternate wetting and drying. The alternate wetting and drying will not show the that much effect on the disintegration, but it will lose or weak, try to weak the structure of the rocks, but it will take a lot of time for the breaking. Okay, in summer, in rainy season, it will become swell by absorbing the water, and dry season it is become the shrink. So like that gaps also we can find like we can say because of alternate wetting and drying, the rock will absorb, it will develop cracks. Because of development of cracks, it will get disintegrated. Okay, this is because of the alternate wetting and drying. The diagram we can see here like this. This is a complete one consolidated rock. Because of the constant swelling and shrinkage or the action of the rainfall, the gaps is cracks is developed on these consolidated rocks. It's the effects of the swelling and shrinkage. This is because of the losing or weakening of the structure of the or the bond present between the minerals element. Okay. Next one is the glacier. Okay, this action of glacier also only active in the cold region. Here the snow will fall, it will accumulate and change into ice sheet. Okay, but when the temperature will change, this ice sheet will try to ice sheet will start to move from higher slope to the lower slope. When we will start or when we will move over the rocks or on the rocks, it will show the tremendous pressure. When it will show the tremendous pressure, rocks will start to disintegrate. When some part of disintegrated rock, it will carry this loose material will carry up to the lower slope and it will deposit it. So finally, the ice it will deposit it, the loose material, also the plant debris and other material, solid material, into where region, warmer region, where it will deposit the warmer region or where the low slope is there. Okay, when it will move, it will carry with it loose material and plant debris. Okay, and this loose material plant debris is called the moraine. It is happening because of glacier, because of the change in temperature. Next one in the wind. Wind is most active in the desert area. It will show the erosive and transporting effect. When it will move from one location to other location, that wind will carry the fine material like sand, silt, and clay particles. When it will come in contact with the rocks, it will show the abrasive effect on the rocks, and rock will start to disintegrate because of the tremendous force applied on that rocks and the abrasive effect between the rocks and the wind. And next one is the atmospheric electrical phenomena. It will be we will see in the rainy season. Lighting will happen. That lighting will break the rocks. So because of the glacier movement, we can see the cracks will develop, cracks and scratches on the rocks. This is because of the disintegration of rocks because of the wind. Will show the abrasive effect on the rocks. And this is a lightning effect in the rainy season. Then the rocks will get break. Next one is the chemical weathering. So we are discussing next process, that is chemical weathering of the rocks and minerals. So how physical weathering and chemical weathering different from each other? Chemical weathering will do the disintegration of the rocks, whereas the physical weathering will do the disintegration of the rocks, whereas the chemical weathering will do the decomposition of rocks. Disintegration means the lowering the size of the rocks, decrease the size of the rock. Where decomposition is the change in the chemical composition of the rock and formation of the new rocks or minerals. So that thing is happening in the chemical minerals, where the new rocks will form, means new minerals will form from the previous mineral, means conversion of the primary mineral into secondary minerals, or we can say the conversion of the primary rock into the secondary rocks. Okay, this is the basic difference with the physical weathering and chemical weathering. Whereas in chemical weathering, just the disintegration or the lowering of the rock size will occur, whereas chemical weathering, complete rock will change, new composition will form. Okay, so chemical weathering is active, or it will be become faster when we'll have sufficient amount of the water, temperature, and the organic matter. Generally, organic matter, why it is important? Because it will release the more CO2. Okay, and the organism. These four factors responsible for the chemical weathering. If this four factor is there, then only chemical weathering will be faster. Okay. Now we'll see the one by one the process of the chemical weathering, which process will be active, which is most important. First one is the hydrolysis. Hydrolysis is the splitting of the water molecule into the H and the OH ion. That H ions will be reacted with the primary minerals which is present in the rocks, and it will react with the primary minerals. It will convert the complete primary mineral into the secondary minerals, and the result of the hydrolysis will be the clay. It may be the clay, it may be the basic ions, maybe metal ions, maybe positive or negative charge, and the soluble silica. Hydrolysis occur, it will occur two times. Means two times hydrolysis should happen, and two H plus ions should react it with the primary mineral. Then only primary minerals will convert into the secondary minerals. Okay, that's why this hydrolysis is called the double decomposition process, because hydrolysis should happen two times, convert primary minerals into the secondary minerals. The result will be the hydrolysis will be the clay particle or metal ions and the soluble sigma. So this is the most important process for the formation of the clay. This process is only responsible for the formation of the clay. Among the all chemical process, this is the process will helpful only important for the formation of the clay. Next one is the oxidation and reduction. We have just discussed about when hydrolysis will occur, different types of the metal will release. It may be calcium, it may be magnesium, sodium, potassium, iron, aluminum, all those metals will release. Okay. When it will release, then oxidation will occur. It will it will oxidize the iron, like iron will release, it will oxidize the iron, it will convert into the ferric oxide. That ferric oxide nothing but the hematite, which will give the red color to the redstone. Oxidation will bring the color to the soil. Okay, so oxidation is the addition of water molecules to the one minerals. Okay, mineral formula. Reduction is the reverse of the oxidation. It will remove the oxygen and it will also give the color to the soil. Next one, hydration. This hydration process will be active after hydrolysis, oxidation and reduction, then the hydration. Okay, so hydration also will change the chemical structure of the minerals. So, for example, hematite is there. Hematite is combined with the water molecules. It will convert into the hematite will convert into limonite. So, limonite will give the yellow color to the soil. For example, the formation of gypsum, calcium sulfate will be there. Calcium sulfate will react with the water molecules. That the combination of attachment of water molecules to the any minerals, that is called the hydration. The hydration will bring out will form a new mineral, that is the gypsum. Okay, this is the again important process for formation new mineral. Next one is the solution. How solution will do the decomposition of the rocks and minerals. Generally, only soluble rocks only will get decomposed, not resistant rock which is not soluble in the water. Like halite is there, halite only will get decomposed because it's soluble in the water. Soluble in the water. Next on the carbonation. Carbonation is the process of the formation of carbonic acid by reacting the carbon dioxide with the water. So this carbonation will bring the decomposition of the rocks and mineral. Only the soluble compounds will get dissolved and bring the decomposition of the rocks and minerals. This is most active in the desert area where the calcium, calcite, or dolomite will present. For example, there were secondary minerals there like sedimentary rocks, secondary minerals, secondary rock, that is limestone. Limestone rock will have the mineral like calcite and dolomite. That calcite and dolomite will be the soluble in the uh, carbonic acid, which is formed by the carbonation process. That calcite and dolomite will become solubilized and decompose the rock. The final product will be the calcium and bicarbonate and carbonate. Okay, so this is we have discussed till now up to the physical weathering and the chemical weathering. So next one is the third process of weathering is the biological weathering. So biological weathering requires the living organism like man, animals, plant, plant roots, then the microorganism. So we'll discuss for the animals, man and animals. How man and animals will bring the disintegration and the decomposition, the rocks and minerals. So we know that man for build the dams, channels, and construction of roads, we have to disintegrate the rocks. During disintegration, mass will play the major roles. Okay, this is the one factor for disintegration of the rocks and minerals for building the dams, channels, and construction of the roads. So this will increase the surface area of the rocks, which will helpful for the chemical weathering. Next, we'll see that some animals, birds, insects, worms, they will make some holes in the rocks, which will help for the weathering. When they will stay in the holes, also they will release some different types of the organic acid. That acid will react with the rocks and start the decomposition of the rocks. Okay, sometimes termites, ants will be there in the humid region. Will also develop the galleries, passage, and also and develop the galleries and passage, and also secrete some acid. That acid will bring the decomposition in the rocks. Another example is that the rabbits will destroy the soft rock by burrowing into the rocks. And these are some example of the biological weathering. Next one is the plants and its roots. When plants roots will penetrate into join the crevices of the rocks. When plants start in the will start in the growth, that plant's roots also will increase its value. When it will increase the value, it will show that it will exert a tremendous pressure in the crevices and started the disintegration of the rocks. Another factor for the disintegration, that is the when the roots will present in the crevices of the rocks or joints of the rock, it will release the CO2 or different types of organic acid. So organic acid will react it with the rocks and it will leach out the soluble parts of the rocks and will start the decomposition of the rocks. When it will release the CO2 from the root, the root will react with the water and form acids. So like that, plant roots will helpful for the weathering of the rocks. The next one is the microorganism. When microorganism is survive on the earth, during that process, it will release some organic acid, and that organic acid will react with the rocks, and rocks will get the uh, weathered. After that, we are going to discuss about the factor responsible for weathering of the rocks or minerals. There are three major factors responsible for weathering of rock, or we can consider this a very important factor, will helpful for the weathering of the rocks. That is the climatic factor, physical characteristics of the rock and minerals, and chemical and structural characteristics of the rocks and minerals. In climate, it's very important for the weathering of rocks. Generally, if you consider the weathering process, which climate it will be more active, that is the humid climate. In humid climate, weathering will be the very faster compared to the desert climate and the temperate climate. Because in a humid climate, temperature as well as the rainfall will be more active. Because of the temperature and rainfall is more active in the humid region, three weathering will be active simultaneously. First is the physical weathering, chemical weathering, and biological weathering. Okay, these three processes will be active in the humid climatic condition, whereas in the temperate region and the desert region and the arid region, only physical weathering is active. Only physical weathering is active. That's why the weathering will be fast in the humid region as compared to the desert and temperate region. Because weathering is mostly depends on the which types of the factor is available, or which type of environmental factor is present to weather the rocks and minerals. Only the humid condition, water will be there, organic matter will be there, vegetation is there, microorganism there, then rainfall is there. Okay, the temperature also is there. So all these factors combinedly will attack on the rocks and minerals and decompose fastly as compared to the desert, or we can say the arid and temperate region. In arid region, only physical weather will active. Because of that is also because of temperature. That's why in that condition also soil formation will not be proper. Okay, this is the effect of the climatic condition. Next one is the physical characteristics. Physical characteristics means the different composition of the rocks. If the rocks will have the more number of minerals, that rock will be weather fastly compared to the rocks will have only a few, means one or two number of the minerals. The higher the heterogeneity of the rocks, more the weathering of the rock, more the sensitive to the weathering of the process. Or also depends on the which types of the minerals present in that rock. If the rocks will have the ferro magnesium minerals, that rock will weather fastly than the rocks will have the non-ferro magnesium minerals. For example, basalt rock is there. Basalt rock will weather more fastly than the granite, because basalt rock will have the ferro magnesium minerals like biotite will be there, then hornblende will be there, olivine will be there. That one weather fasting. But whereas the granite is there, granite will have the quartz, in muscodite, it will show the resistance to the weathering. So based on the composition also, weathering will decide. The next one, the particle size. Next one is the particle size. The fine size basalt rock is there, and other side is the coast size granite is there. So fine size basalt will weather faster than the core size granite, because the core size granite will have less surface area for the chemical weathering, whereas fine size basalt will have more surface area for the chemical weathering. That's why the particle size also will matter for the weathering of the minerals. Next one is the hardness and degree of cementation. If the more the hardness of the rocks, then the more resistant to the weathering. For example, is the sandstone is there. Sandstone, it will show the more resistant to the weathering, but will have the more highest amount of the quartz. Quartz will have a more hard structure. Okay. Next one is the chemical and structural characteristics of the rocks. You will see the chemical characteristics of the rock, like gypsum, which is strongly soluble in the water and the acid. So such types of rock will weather fastly compared to the rock which is not soluble in the water and organic acid. For example, quartz is there. Quartz will not soluble in the water and organic acid, so it will show the resistance to the weathering. Whereas the ferromagnesium mineral also weather fastly compared to the non-ferromagnesium mineral, which is chemical composition. Next one is the structure. If the open structure mineral is there like olivine, it will weather faster than a closed type structure like feldspar. Then the tightness of the crystal. If the less tight crystal is there like olivine and biotite will weather fastly compared to the tightly packed crystal like muscovite and quartz. So what is the weathering product of the different minerals? So olivine when we weather, it will form the serpentine mineral, limonite and hematite and quartz. Pyrogen will form the clay, calcite and limonite. Amphibole will form the hematite and quartz. Pelagic will form the clay, quartz and calcite. This is next one we're going to discuss the weathering sequence. So which mineral will show the more resist to the weathering? So this weathering sequence is given by the Goldrich in 1938. So quartz will show the more resistant to the weathering, followed by the muscovite. Muscovite is the potassium containing feldspar. After that, sodium and calcium feldspar, biotite, followed by the agatite hornblende, then olivine, calcite, and gypsum. So among this series, calcite, gypsum will show the least resistance to the weathering, whereas quartz will show the highest resistance to the weathering. So after that, Bowen will have the given the one theory, that is Bowen reaction theory. He said that at higher temperature, some rocks will get crystallized. That rocks will weather fastly, whereas the some rocks or minerals, sorry, those minerals will crystalline first at high temperature will weather fastly, and those mineral will crystalline at lower temperature or it will take a time that will weather with that mineral will show the resistance to the weathering. For example, olive wine, it will crystalline first at high temperature. It will weather fastly. Whereas quartz is there and feldspar is there, it will show the resistance because it to the weathering because it will crystalline at last. Means who will crystalline first? It will not show the resistance to the weathering, but who will crystalline at last? It will show the resistance to the weathering. Okay. Now, this is the part for the weathering of the rocks. We are discussed up to here. What is weathering? Then how weathering is occur? What are the process and the product of the weathering? So finally, we will get the regolith from the weathering. Means one parameter we are getting from the weathering process. So we are getting parameter from that weathering process that is called geological weathering. Okay. Weathering, we can say it is the destructive and the constructive process. Weathering, we can say is the destructive and constructive process because when weathering will start, weathering is called the destructive process, whereas the soil formation is called the constructive process. Okay. So we will now discuss about the soil formation. So soil formation means the development of soil means the development of soil profile will have the five horizon. That is the complete soil development. So first process is the weathering of rock into regolith. So regolith will be the parent material. Then formation of true soil from the regolith. Okay, that is the formation of soil. When weathering will start, it will disintegrate the consolidated bedrock into the regolith. That is called the destruction of the rock. That is called the destruction of the rock. Now, regolith will convert into the soil. In this process, what we are going to do, we are doing the destruction of the unconsolidated bedrocks, the parent material, and the construction of the soil. And the construction of the soil. Indirectly, we can say the weathering is the destructive process. The soil formation is both constructive and the destructive process because weathering regolith will disintegrate in the soil and the soil will form. That's why it's called the constructive and destructive process. Okay. So then what are the factors responsible for the formation of the soil? So first, who have discussed the soil formation, who have observe the different types of soil on the Earth's surface, that is the Dokuchi. Dokuchi is the father of the modern pedology or modern soil, who only have observed that the different soil and the different soil forming factor. He has given the three soil forming factor, the climate, organism, and the paramaterial. He said that soil formation is a function of climate, organism, and the parent material. After that, he is from the Russia. Dokuch is from the Russia. After that, Jenny is there, another scientist from the America. He have given the five factor for the soil formation. That is the climate, biosphere, relief, paramaterial, and the time. These five, he said that according to these five factors, soil will form. Okay. After that, Jenny has given the another classification. He said that climate and the biosphere is one group, and the relief parameter time is the one group. Means Jenny had divided this, Joffrey had divided this five factor into two groups. That is active factors, another is the passive factor. Climate and biosphere is called the active factor, then relief parameter and time is called the passive factors. Okay. So, on what basis you have classified active factor and passive factor? He said that relief, parameter, and time, it is the base or it is the source for the formation of the soil. Whereas that's why it's called the passive factor. Whereas climate and biosphere, it is the agents for the formation of the soil. That's why it's called the active factor. Means it will give the energy for the formation of the soil. Also, Jenny have different. Jockey have given the two soil, that is endomorphic soil and the ectomorphic soil. He said that soil which is developed by the influence of the climate and biosphere, that soil is called ectodynamorphic soil, whereas the soil will form because of the influence of the relief parameter time, that is called endodynamorphic soil. Okay, means the soil property is depends on the relief parameter and time. That soil is called that soil is called the ectodynamorphic soil. If the soil property depends on climate and biosphere, is called endodynamorphic soil. Then we will see here one by one the parent materials, how the properties of the soil depends on the parameter. So we'll say the parameter is the basic mass of the soil formation, or if you want to decide what is meant by the paramaterial. So paramaterial is the initial stage of the soil formation, or you can say the zero stage of soil formation means the paramaterial. Okay. So there are different types of paramaterial will be there, will be inorganic or the organic. Based on the parametric, different soil properties will be there. Okay, so soil parameter will be organic will be there and inorganic will be there. Then again, inorganic parameter will be there. Again, two types there. That is the transported parameter and another one is the residual parameter. So transported parameter again we have the different. We have given the different name based on the agency. Is the parameter transported by the water? We have given the name alluvial, marine, or lacustrine. If the parameter transported by the gravity, we have given the name the colloidal parameter. If the parameter transported by the wind, we have given the name Aeolin and Lois. If the parameter transported by the ice, we have given the name Moraine and Silt. So based on the agency, we have given the name to the parameter. Okay. How parameter will bring the changes in the soil properties. For example, you consider two parameters, that is parameter like basalt parameter and the granite parameter. Basalt parameter will give fine texture soil. Okay, whereas coarse parameter, that is granite, will give the coarse texture soil. Okay, soil texture, water holding capacity, and the drainage of the soil, it depends on the parameter. Okay, mostly physical properties of the soil, it depends on the parameter. Okay, which types of parameter means which types of the rock is there, which types of material is there. Okay, so other properties also there, which is depends on the parameter, that is the depth of the formation of the soil. Okay, means the coarse texture rock is there, means deep soil will form, and the fine texture rock is there, means shallow depth soil will form. Okay, so this is about the parameter. The next one is the relief. Okay, relief is the unconsolidated area on the earth surface. Okay, uneven area on the earth surface, that is called the relief. Okay, relief also we can the topography. Relief we can say the topography. Okay, now suppose slopey uneven area is there, we can say the relief. The relief will change the microclimate of that particular region. Okay, now we can see how soil will soil property is different from the soil different at one particular area in that particular relief. Now here you see the at highest point of the relief, here the well developed soil we can get. Well developed soil we can get means here we can see five master horizon, and O will be there, A will be there, B will be there, C will be there, and the R will be there. But if you see here, we will see poor development of soil means the good or the great soil development of at the top of the relief. The poor development of soil will be there in this area. Then again average soil development will be there. Then again good soil development will be there. So relief on relief different types of soil we can see. And different types of soil properties we can see. And soil property is changing because of two factors. One is the erosion and the drainage. If the more drainage, complete soil will develop. If the more erosion, poor soil will be developed. Now, if at the top of the relief, if you see here, the erosion is less and drainage is more. That's why the deep soil will develop. Whereas at this area, the erosion will be more and the drainage is less. That's why the poor deep soil will develop, the shallow soil will develop. Only we can see here the paramaterial, no soil we can see. We cannot see the horizon formation. We cannot see the A horizon, B horizon. Only one type of horizon will see because almost here erosion will occur. After here, if you go some this area, some soil development we can see. Okay, some soil development we can see because here the erosion will be less. At the down here, the erosion almost zero, and the drainage will be more. So drainage will be more means you can see the different layer one, two, three. More layer formation will be there because of the drainage. More the drainage, more the soil formation, and more erosion, poor soil formation. So this is the effect of the relief on the soil formation. Next one is the time. Means how much time it will take to develop the complete soil. Okay, the conversion of the zero developed soil into the mature soil. It means that conversion of the zero horizon into the five horizons. Okay, is conversion of the paramaterial into the horizons into the soil will have the five horizons. That time is called the pedological time. That time is called the pedological time. When soil will start mature, means when soil will convert from paramaterial to soil, means it's called soil will converting from early mature state to the complete mature state. Then the the soil will properties of the soil also will change. And the organic matter content will increase. Then the clay formation, clay content will increase. Okay, like the depth of the soil will increase, the different horizon we can see, color of soil will change. Okay, water holding capacity will increase. Then we will see the variation in the texture. Okay, so this thing we can observe in the complete soil. Then how parameter will get better with the time. So that time we had different divided into five stages. Okay, the first one is the initial stage. In the initial stage, there are five stages there. In initial stage, we'll say the only the parent material, that is unweathered rock. In juvenile stage, just the weathering will start. Okay, there we cannot see the clay concentration or clay content. Then virile stage will be there. In virile stage, easily weathered rock will decompose and clay content will increase. The fourth stage will there say that almost all the rocks will whether clay content also will increase, water holding capacity also we can see, depth of the soil will we can see. Only most resistance rocks will not be most resistant rock will be there, that will not be weathered. So at the final stage, it will get weathered. Okay, means initial stage we can see the parent material, and the final stage we can see the matured soil. So in that soil, mature soil we can see the your complete we can see the complete horizon. There's five master horizons. Okay, the next important factor, that is the climate. The climate we are considering into the active factor. So this climate If you decide the if you see parametrials, passive factor and the active factor, okay. So passive factor, that is the relief parametrial end time. So this will have passive relation with the soil properties, and the active factor will have, okay, the direct relationship with the soil properties. Yeah, means I want to say that the soil properties and this factor will have weak relationship. Means if you see parametrial and soil particle have a weak relationship. Weak relation means is what? The early stage of the soil development, the properties of the soil, it depends on the parameter. But when soil will start developing in the advanced stage, same soil properties, it depends on the climate and vegetation. Means, for example, your basalt rock is there. Okay, that basalt rock is converted into the black soil or fine texture soil. That is because of the parametric properties. That is means because of the basalt rock. But in that region, if the rainfall is more than 2000, same soil is converted into the red soil. Okay, it means that there the advanced stage of soil is red soil, and if that soil is converted into red soil, black will convert to red soil because of the rainfall. Means the advanced stage soil property is depends on the climate, and early stage soil properties is depends on the parameters. Okay, when we start, when the soil will mature, the properties of the soil will depend on the climate, not on the parameter. Only the early stage properties of the soil will depend on the parametrial, whereas advanced stage soil properties will depend on the climate. Okay. So in the climate, there is a two factor is very important for the formation of the soil. That is, one is the rainfall, another one is the temperature. For the mature soil, for the formation of the complete soil, most important process that is responsible for the formation of complete soil or formation of the mature soil, that is the leaching and the percolation. More the leaching, more the development of soil. More the percolation, more the development of soil. And that is possible only when the rainfall is there. Okay. If you will see in India, from climatic region, from the west side, if you see the soil of the west side, if you see the soil of the east soil, we can see the much variation in the soil properties. Now we see the soil of the arid region, we will see the desert soil. Because in desert soil, weathering is not possible because of the less rainfall area. Because weathering is not there, less rainfall is there, means the leaching is not possible. Leaching is not there, it means that the depth of the soil will be less. The depth of soil will be less, means there the soil development will be less. Okay, and we will see the semi arid and semi arid region, uh, the calcium carbonate and gypsum concentration will be more because of there is a leaching of the calcium carbonate and magnesium carbonate is not occur because of less rainfall area, and there we cannot see the complete mature soil. Because in the B horizon, we will see in the arid region, you will see the calcium carbonate deposition or accumulation. But if you go the northeast region, by the east area of the India, that is northeast area, you will see the complete soil development. Okay, complete soil development means that you will see the five master horizons, or we can see the four master horizon. You will see A horizon, you will see B, C, and R. But if you see the arid region only, you will see A horizon. That's all. A horizon, B horizon. That is also incomplete development. Okay, so development of soil in the east area because of the more rainfall. Because more rainfall will bring the translocation of clay, translocation of the elements. Okay, means it will bring the leaching, it will bring the percolation of the water. This leaching and percolation of the water responsible for the development of complete horizon. Okay, and next factor is the temperature. Temperature responsible for also responsible temperature also responsible for the development of the soil. Okay, now in arid region compare, in arid region is high rainfall is there, sorry, high temperature is there, the accumulation of salt will be there, accumulation of salt will be there, accumulation of salt is there, means the leaching is not possible. because the high evaporation will be there, high evaporation rate will be there. There, the development is not possible. But here you will see the northeast area, high temperature there, and the vegetation also will be more. Vegetation is effect of vegetation on the soil property means organic matter will be more, decomposition of the more because of the high temperature, and we will see the depth of soil also will be more. It's because of the climate. Completely, we have to have to understand the soil formation or to understand the effect of climate on soil formation. We have to compare the arid soil and the heat soil. We will see the complete change. The next one is the vegetation, effect of the vegetation soil property. We cannot differentiate the effect of vegetation and climate separately. Okay, whereas the climate have the effect on the vegetation, and the vegetation will have the effect on the soil properties. If you see the soil of the area will have the more vegetation, you will see the vegetation like coniferous tree, hemlock tree. Okay, because the tree responsible for the that tree will develop more organic matter, and that organic matter responsible for development of the soil. Whereas the semi-arid region rainfall is less, in that region only we will see the grasses. That grasses will hold the more element, and then the leaching is not responsible. Then the leaching is not there, then the soil formation is not possible. Okay, the leaching is very important, and the leaching is only depends on the climate. Okay, now you see effect of vegetation. So we can see here the desert soil is there. Effect of soil element also is less because here the leaching is not possible. The low rainfall area there, and the this desert area will have such types of trees will capture the more bases. Will not allow to go to leach down. Now we go to semi-arid area. We'll have the some amount of development will be there because of quantity of rainfall will be more. When the quantity of rainfall will be more, then leaching will start. Now coming to the humid region, where humid region rainfall will be more, development of soil will be more. Okay, and this is the example of the humid region. This is the arid semi-arid region. Thank you. We are going to stop here. We will discuss the process of soil formation, that is fundamental process of soil formation, and the pedology process of soil formation in the next class. Thank you so much.